So now we're doing topic 4.1. It's the first lesson of topic 4. The items that you're going to need are your notes and your pencil. What our objective is, what you need to learn today, is how to understand and use the property of equality. We've talked about equality before when we talked about equations. Remember, equations are math problems with equal signs in the middle. And what that means is one side of the equal sign has to be balanced or the same as the other side of the equal sign. If I have an x on one side, it has to equal the x on the other. If I have 7 rocks on this side of the scale, I have to have 7 rocks on this side of the scale because they have to stay balanced. That's what that equal sign in the middle means, that both sides are balanced. This is really important when we start getting into algebra to understand that both sides have to be the same weight. So the first thing we're going to talk about is the property of equality. So put Roman numeral 1 and put the property of equality. Equations have to be balanced on both sides of the equal sign. So first we're going to talk about A is the addition property of equality. And I drew this little scale here to try to show you that one side of the math problem has to be equal or balanced to the other side of the math problem. So if I had the math problem 5 plus 2, it has to be a plus because this is the addition property. 5 plus 2 is balanced or equal to 7. Both sides of my scale weigh the same amount. If I had a 9 here instead, it wouldn't weigh the same amount. It would be off balance because 5 plus 2 is not equal to 9. So we want it to look the same on both sides of our scale. Another way of seeing this would be like 4 plus 1 is balanced or equal to a 5. They're both weigh the same. So what I want to show you is what we do with the addition property of equality. If I had that 4 plus 1 again, if I had 4 rocks and then 1 more rock, 4 plus 1, on the other side, I needed to have 5 rocks in order for it to stay equal. But what if I added 2 more rocks to this side? What would I need to do to the other side of the equal sign to keep the scale balanced? I would need to add 2 more rocks. Well, let's make sure mathematically that's true. I had 4 rocks, and then I had 1 rock, and then I added 2 more rocks. Is that the same as my 5 rocks plus 2 more rocks? 4 plus 1 is 5, 5 plus 2 is 7, and 5 plus 2 is 7. Yep, my scale is still balanced. What if I had, on this side, some mysterious amount of rocks, x rocks, on the other side I said I wrote 12. If I added 3 rocks to this side, what would I have to do to the other side? I would have to add 3 rocks to keep it balanced, even if I didn't know what this number was. What you do to one side of the equation, you have to do the other side of the equation. So let's look at the subtraction property of equality. It's the same idea, like 12 minus 3, but now subtraction, is equal to 9. They're on the same side. Another way we could write that, though, is 12 minus 3 is equal to 10 minus 1. How much is 12 minus 3? Well, it's 9. And how much is 10 minus 1? 9. So even though they use different numbers on both sides, they mean the same thing, so they're balanced. If I have 12 minus 3 and I take away 2 more, what do I have to do to the other side to keep it balanced? I have to take away 2 more. Let's go back to our rocks. And I write 5 rocks minus 2 rocks, so that's going to look like this, equals 3 rocks. Well, that's true. But what if I take away 1 more rock on this side? What do I have to do to the other side? I have to take away 1 more rock. What if I had x minus 5 equals 12 on this side? I don't know what the x is, but what if I took away 2 more? X minus 5 minus 2. What do I do to the other side? I take away 2 more. I have to say equal. It's the same with the multiplication property of equality. 5 times 6 equals 15 times 2. How much is 5 times 6? It's 30. And how much is 15 times 2? It's 30. But what if I took this whole number and I also multiplied it by 5? What do I have to do to the other side? I have to also multiply it by 5. Now, on a side note, I've heard that some of you are not watching the whole videos, that you're just freezing the frames and then writing down the notes and not listening to the lecture. So if you are one of the good children and you're listening to the lecture, what I want you to do right now is I want you to draw a little butterfly by the letter B over here, and then I'll check to see who the good kids are. Okay, moving on. So what if I had 3 times x equals 21? We don't know what the x is, that doesn't matter. But if I took that whole thing and I multiplied it by 2, what do I have to do the other side? I have to multiply it by 2. The last one is the division property of equality. So if I have 20 divided by 4, that equals 5. What if I have 200 divided by 20, and I have 20 divided by 2? They equal the same thing, 20 divided by 2, yeah, we're good. Okay, and so they have to be equal on both sides. And that's just the whole point. If I divided this whole thing by, 1/4, I would have to divide the other side by 1/4 to keep it balanced. Okay, that's it. I'll see you tomorrow.